So, dear students, today we'll be discussing the problems of alternating currents. So, very important problems which has been asked in the board exam. Okay. So, I hope everyone is able to see the screen. Correct. So, there are hardly 2 to 3 formulas in this particular chapter. Okay. And if you're able to know the formulas and where to apply what, then that's it. It's very, very easy to get full 5 marker in this particular chapter, alternating current. So, the first question. A resistor, an inductor, and a capacitor are connected in series with 120 volt 100 hertz AC source. Voltage leads the current by 35 degree in the circuit. If the resistance of the resistor is 10 ohm and the sum of the inductive and capacitive reactance is 17 ohm. Inductive reactance, that is basically what? XL. Capacitive reactance, that is basically what? XC. It is 17 ohm. Calculate the self-inductance of the inductor. And normally in the examination, they will give what is the tan 35 value. So we know the formula tan phi is what? XL minus XC by R. Correct? So tan 35 value, they will give it in the examination. Okay, so no need for us to buy heart, or else they'll give the logarithm book where we can find a tan 35. Mostly in the examination, they'll give the tan 35 value. So tan phi is equal to XL minus XC by R. Correct? So what is my resistance given? 10 ohm. It's given in the question. So XL minus XC is 10 into tan 35. Okay, tan 35 value is 0.7. So 0.7 into 10 is 7. So XL minus XC is what? 7. And also in the question, it is given sum of the inductive and capacitive reactance here. As you can see here now, I'll just draw it for you guys. This one. Sum of the inductive and capacitive reactance is how much? 17. In the sense, XL plus XC is equal to 17. XL plus XC is equal to what? 17. Okay, then we have to add the two equations, simultaneous solving by using elimination method. Add it. Then I'll get what? 2XL is equal to 24. So XL is what? 12 ohm. The question is, what is the value of inductor? What is inductor? L. L is inductor, C is capacitance. The question is, what is the value of inductor? And XL, there is a simple formula, 2 pi FL or omega L. Correct? So 2 pi FL. Frequency is also given in the question. It is 100. So 2 into 3.14 into 100 into L. I'll get L value also. Very easy calculation. So any doubt is there? Once the class is over, I'll help you out on the same. Okay. I think everyone has reached, I think so. Perfect. Yeah. 56th question. A series LCR circuit is connected to a 220 volt AC source of variable frequency. The inductance of the coil is 5 Henry. Capacitance of the capacitor is 5 microfarad. Micro in the sense you have to put 10 power minus 6. And resistance is 40 ohm. At resonance, calculate the resonant frequency. So we know the resonant frequency formula is what? FR is equal to 1 by 2 pi root LC. Everything is given in the question. L is 5 Henry. Capacitance is 5 10 power minus 6. Okay, and pi value is 3.14. Second question is current in the circuit. See, and what is given here? An LCR circuit is connected with what? 220 volt, right? Yes, I is equal to what? V by R. V RMS. V by R. V is what? 220 volt. Correct? 220 volt by 40. Simple substitution. So, in alternating current chapter, whenever they ask you the current, let it be in entrance or in board, it is simple I is equal to V by R. We need not panic. Think this is some complex thing. 99% of the answer is I is equal to V by R. And obviously there is exception, but I'm just telling you the shortcut. So we need not panic in any of these things. Next one, inductive reactance. XL is equal to 2 pi FL. Same formula. Frequency is given. Correct. That is what the resonant frequency we just now found out from this. So all the calculation you have to do. Okay, then only will be getting it. So XL is equal to 2 pi FL. If we just do it, we will be getting the answer for that also. Now I'll go to the most important question in this. Yes. 65th question. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and a resistor of resistance 40 ohm. Correct. Find the resonant frequency. Resonant frequency is what? 1 by 2 pi root LC. So L is 5 Henry. What is capacitance? 20 microfarad. 20 into 10 power minus 6. So as I already told you, we are using same formula again and again. And once we do the calculation, we'll be getting the resonant frequency, that is FR or F naught value. Find the resonant frequency circuit is done. What is the impedance of the, what is the impedance at resonant condition? So whenever I say the impedance at resonant condition, at impedance, the circuit will become what? Pure resistive, because XL is equal to XC. So Z is equal to root of R square plus XL minus X the whole square. And XL is equal to X in the sense, my circuit, that the impedance circuit will become what? Pure resistance, and Z is equal to R. So what is the resistance value? 40 ohms. That's it. For this, they are giving us 5 mark for this understanding purpose. Okay. And then 64th question. A 20 ohm resistor, 1.5 Henry inductor, and a 35 microfarad capacitor connected in series with a 220 volt, 50 hertz AC supply. Calculate the impedance of the circuit and also find the current through the circuit. Okay, they're asking about impedance. Yes, and what they given? Impedance is basically what? Z. Z is equal root of R square plus XL minus XC the whole square. That I have to find. Correct? So I have to find what? The resistance. Is it given? Yes. A 20 ohm resistor is given. But XL and XC is not given. So I have to find XL is equal to what? 2 pi FL. The formula. XC is equal to what? 1 by 2 pi FC. Okay. Frequency is 50 hertz. Correct. Inductor is what? 1.5 Henry. So like that you will find XL. XC 35 microfarad. So 1 by 2 pi FC. 1 by 2 pi F into C. C is 35 into 10 power minus 6. Correct. Then Z is equal to root of R square. R is nothing but what? 20 square. Plus XL minus 6 is the whole square. So substitute all the value, we'll get what? Z. Next question is nothing but also find the current. I told you if the current is there, it is simple thing. I is equal to V by R, or in this case, it is V by Z. V is what? 220 volt by Z. Whatever we got in the above value, we just substitute it. That's it. Impedance. 3 direct question. Again, an easy 5 marker. Let's take this question 62. A sinusoidal voltage of peak value 285 volt is applied to a series LCR circuit in which the resistor of the resistance 5 ohm, pure inductor of inductance 28.5 millihenry, and a capacitor of capacitance 800 microfarad are connected. Find the resonant frequency. Again, resonant frequency, what is the formula? FR is 1 by 2 pi root LC. Calculate the impedance, current, and power dissipated. Power, P is equal to VI. That is the formula of power. Okay, P is equal to VI. So first thing is resonance. Resonance is what? 1 by 2 pi root LC. Substitute everything. What is my inductance? 28.5 millihenry. So 28.5 into 10 power minus 3. Milli meaning 10 power minus 3. Then capacitance 10 power minus 6. 800 into 10 power minus 6. So substitute everything and we'll get the resonant frequency. Second question is what? Calculate the impedance. So at if the circuit is at resonance, impedance is equal to what? Pure resistive circuit. So Z is equal to R. Z is equal to 5 ohm. So I is equal to V by R. I got current value. Correct? Voltage value is given 285 by impedance, whatever we got. It is resistor value 5 ohm. Why it is 5? Because during impedance, during the resonance, the circuit becomes purely resistive. In the sense, Z will be equal to R. That is a condition. Okay, and the power dissipated formula. I told you the power here is what? VI. Correct? So once the power dissipated formula for this case is what? I naught V naught by 2. Okay, and we'll just substitute all of the values to get the power also. So this is again an important question too. So like that, the questions are all similar questions in this. So any doubt or anything, please let me know. now.